In this lesson, we're just starting some properties of our logs here. So for example, one property is that if I have a log here, but it also has an exponent within it, if the bases are the same, then they just cancel each other out. And the solution is the exponent. So in this case, it was 3. Because again, here, as you see, and I'll erase, the base of the log is 2, as well as the exponent here, the base is 2 being raised to the third power. So again, canceling out, and here I'm left with just 3. And then if it were written even the other way, notice how I have an exponential, but then in the exponent it's a log. So if I have a base of 3 with that log here, a base of 3. Again, canceling out, bases are the same, and I'm just left with 7. Now here, to solve this, we could do change of base, right? Where you've got the 2 logs, so log 8 divided by log 2, right? Because base goes in the bottom. Now, just to show you another way, here, again, using this property, how the bases, if they're the same, then we can convert and cancel out. So here, the goal is log base 2. So if I could write 8 as a base 2 to an exponent, then I could cancel out. So 2 to the what power could give us 8? Well, 3. 2 to the third power is 8. So now that the bases are the same, they cancel out, and the solution is 3. And if you were to put this in the calculator, you would also get 3. So here, we're going to add together. I notice that my bases here are the same, so they cancel out, and I'm left with 4. Now I'm going to add to that. Now here, again, we could do change of base or rewrite 25. So here, if I've already got log base 5, then if the base is 5, and that's what we're canceling out, then I write 25 as a base of 5. So 5 to the what power is 25? 2. 5 to the second power. So now the bases are the same, cancel out. So this is just 4 plus 2, which is 6. Go ahead and pause the video now and try these U-tries on your own. And here we go. So again, here, without using or trying the change of base formula, log base 4 of 16. So if the base was 4, then 4 to the what power gives you 16? 4 to the second power. So now that the bases are the same, cancel out, and you're left with 2. Same thing here, log base 6. So now base 6 to the what power gets you 216? 3. Cancel out the bases, and you're left with 3. Then again here, log base 3. So if the base is 3, then 3 to the what power is 81? 4. Bases are the same, cancel out, and you're left with 4. So then here, you've got log base 2. Then base 2, so 2 to the what power is 32? 5. So now here, I cancel out, and I'm just left with 5. So 5 minus. Now here, it's already written, but bases are the same, so they cancel out, and you're left with 3. 5 minus 3 is 2. So then another property here is, and we've talked about this previously, how the natural log and e. Well, they are inverses of each other, so they just cancel each other out. So if I've got natural log and e together, they just cancel out. And my solution here is simplified is 0.15 times t. And that's it. The same thing here. If it's written as an exponent, so e to the natural log power. Again, they cancel out, and I'm left with x plus 1. Same thing here. I've got natural log e, cancel each other out, bring down 2x. Same thing here. Plus, bring down x. Now combine, 2x plus x is 3x. Go ahead and pause the video now and try these U-tries on your own. And here we go. So again, inverses cancel out, and you just bring down. So here I've got 25x. Same thing here. Canceling out, bring down x plus 2. Then last here, they cancel each other out, natural log and e, so I've got 4x plus. Same thing here. Inverses cancel out, 2x plus 1. Now combine like terms, and you got 6x then plus 1. Remember, right, be careful, don't combine like terms here, or don't combine because they're not like terms. This is 6x plus 1, so just leave it 6x plus 1. So now here, another property, and we're going to end with this, is we can do what's called expanding and condensing. So expanding is like using our power property here. So here, notice how I've got log base 3 of x raised to the second power. I can expand this log by taking my exponent and bringing it down in front as a coefficient. So this is 2 times log base 3 of x, which is the same as if I fully wanted to expand log base 3 of x plus log base 3 of x, because there are 2 log base 3x. So this would be the expanded. So again, same thing here, right? Even with a natural log. If I have an exponent, I can bring that down. So this is 3 times the natural log of 3y. So again, this is also natural log of 3y plus natural log of 3y plus natural log of 3y. Because again, there are 3 natural log of 3y's. So again, expanding, I can take that power and bring it down as a coefficient. So another that we'll be talking about is, now this is just log of 4 plus log 2. Now keep in mind our common logs, but in the end, they are the same base still. Notice how we have multiple. And when adding, this is the same as multiplying. So when condensing, I've got my logs here, right? Because they have the same base, they're both a common log. So I can condense and write this as 1 log instead of the 2. So instead of adding, this is the same as log of 4 times 2, which is log of 8. So again, this is condensing, writing the 2 logs as 1 log. So condensing. So again, here, I've got 2 logs. However, notice here's another property. Notice the coefficient. So if we have a coefficient, remember it can be written as an exponent. So let's do that first. So this is log base 5 of x to the third power. Then plus, this is again log base 5 of y to the second power, because we're making our coefficient the exponent. Now we can write this as 1 log because the bases are the same. And remember, when adding, we're going to multiply. So this is log base 5, right? Writing it as 1 log. This is x to the third times y to the second power. Now, can we multiply and continue? No, because the bases are different. So this is our 1 log. Go ahead and pause the video now and try the U-tries on your own. Keep in mind with your expanding and condensing. And here we go. So here you could have noticed that I'm expanding and I've got an exponent here of 4. So I can bring my exponent down. So this is 4 times log base 2 of x. Or you can write log base 2 of x 4 times. So log base 2 of x plus log base 2 of x. So and 2 more times here. Then condensing. So writing this now as 1 log. Are the bases the same? Yes. And notice how we're adding. So we're going to multiply. So this is log base 2 of 5 times 3, which is log base 2 of 15. Now expanding. Again, we have our exponent, bring down as the coefficient. So this is 4 times natural log of 2y. So again, this is natural log of 2y plus natural log of 2y. So again, 2 more times because there are 4 natural log of 2y. Then last here, we are condensing, so writing it as 1 log, but we had coefficients. So you have 2, that can be written as an exponent, so log base 4 of x to the second power. Same thing here, 6 can be written as an exponent, so plus log base 4 of y to the 6th. Now we can write this as 1 log too, right? Because the bases are the same. So this is log base 4. Then we're adding, so multiply. X squared times y to the 6th. Now, can we combine? No, because the bases are different. So this is your 1 log.